Welcome to Spark STEM Scholars.
Today we'll be talking about functions on SAT Math. Let's get started. So what is a function? A function is a factory. This little box is a factory that takes an input, transform it inside, and spit out an output. A function is denoted by f of x, and x is the input. Let's say f of x equals to x squared plus 1. Here, this means that any and every input is squared and plus 1 to get an output. Remember, x is just the placeholder for an input. Let's look at our first example. If f of x equals to x plus 1 to the x, then what is f of 0 plus f of 1 plus f of 2 and f of 3? So here we will just plug in the inputs. So f of 0 plus f of 1 plus f of 2 plus f of 3. This is equal to 0 plus 1 to the 0 plus 1 plus 1 to the 1 plus 2 plus 1 to the power of 2 plus 3 plus 1 to the power of 3 to the power of 3. So you will get 1 plus 2 plus 3 squared plus 4 cubed. This is equal to 1 plus 2 plus 9 plus 64, and you will get 76. Let's move on to example 2. So for what value of x is f of x undefined? Now, a function is undefined when the denominator is 0. This is because we can't divide anything by 0. Dividing anything by 0 will just give you nothing. So here we'll just set the denominator, which is x squared minus 10x plus 25, and set this equal to 0. So this, you can factor it into x minus 5 times x minus 5 equals 0. And x will equal to 5. So this function will be undefined when x equals to 5. Let's talk a little bit about domain and range. A domain is the set of all possible input values, or x, to a function. This will not include, does not include values that lead to undefined outputs, just like the last example. And a range is the set of all possible outputs, or y, from from a function. So let's look at a rough graph from the example above. The example above, we had x squared minus 10x plus 25. This is also equal to x minus 5 squared. So the graph will look like this is around what the graph would look like. As you can see, there's no value at x equals to 5. There's no, it is like an invisible line that the graph never touched. But the graph thus gets closer and closer to this invisible line. This is called the vertical asymptote. But you can also see that the graph doesn't go below this x-axis. This is called the horizontal asymptote. So here, our horizontal asymptote, HA, is equal to y equals to 0. This means that the range of the function is all positive real numbers. So that is domain and range. Let's take a look at our third problem. If f of x minus 1 equals to 6x and g of x equals to x plus 3, what is f of g of 3? So this is called a composite function where you are solving for the function of another function. So first, we will start from the inside and work our way out. So first, g of 3 is equal to 3 plus 3, which is 6. So now we have f of 6. And f of 6, since our function here is given that x minus 1, so what's x to get the 6 in here? The x would be 7 minus 1. And this will equal to 6 times 7. Now 6 times 7 is 42. So our answer to this composite function is 42. Let's look at our fourth problem. F of x equals to x plus 1 and g of x equals to x divided by 2. If f of g of f of k equals to 10, what is the value of k? So again, we will start from the inside and work our way out. First, f of k. F of k equals to k plus 1. So we got our first answer in the inside, and now we're looking for g of k plus 1. G of k plus 1 will be k plus 1 over 2. Now we need to take another f function, and this will be f of k plus 1 over 2, and now we'll plus 1. So this would be our answer, and it is equal to 10. So k plus 1 over 2 plus 1 equals to 10. Now we solve for k. K would be k plus 1 over 2 equals to 9. Now multiply by 2. K plus 1 equals 18. And K is equal to 17. Let's look at our fifth problem. The function y equals to x squared plus 2x minus 4 contains the point m and 2m, with m being greater than 0, which means that's positive. What is the value of m? So try not to get intimidated by all the variables. And so the question gave us a point on the graph. So let's plug that into our function. So this is our y and this is our x. So y is 2m equals to x, which is m squared, plus 2m minus 4. We can subtract 2m on both sides, so we'll get 0 equals to m squared minus 4. Now the m can either be positive or negative 2. And the question said that m is positive, so m equals to 2. Just a little heads up, when they ask for the 0, the roots, and the x-intercept, these are all the same thing. They're just different terms, but they're asking for the same thing. It is the value of x that makes f of x equal to 0 or y equal to 0, or just any value of x that crosses the x-axis. Take a look at this problem, pause the video, and try it out yourself. Okay, so this is our function f, and part 1 is how many distinct 0 does f of x have? Now remember, the 0 is anywhere where the graph crosses the x-axis. And here we have 1, 2, and 3. So we have 3 zeros. Okay, so part 2, if k is constant such that f of x equals to k has one solution, what could be the value of k? In this case, k is our y value. So let's draw a line and test out our choices. Can -2 give us one solution? Let's see. -2 is here, and as you can see, it touches the graph at 2 places. One over here and one over here. That is 2 solutions. We don't want that. So -2 is out. How about 0? Now 0 is here, and that is the x-axis. That is the x-axis, and it touches at 3 different places. So that's not what we want. So 0 is out. And let's try 6. 6 is probably somewhere up here. And the line touches the graph at 1 point. So this could be our answer. Let's check 4. 4, again, it touches at 2 places. So ultimately, our answer is C. Let's talk a little bit about function transformation. Let's say you have a function f of x, and let's draw a graph. Let's say this is f of x. Now we're gonna do. What happens if you negate the graph where you have negative f of x? When this happens, it is flipped over the x-axis. So you will have a graph that looks like this. Now, what if you're adding a value, a to f of x? If you're adding a value, then your graph shifts up. If you're subtracting a, then your graph will shift down a values. Let's move that a little bit. Now, what if you are subtracting inside the parentheses or adding inside the parentheses? Now you're shifting either left or right. Now, this is a little bit counterintuitive. When you subtract a from x, you're shifting the graph to the right side. And if you're adding, then you're shifting the graph to the left side. So in short, when you add a value to f of x or subtract a value from f of x, when you plus a, then the graph goes up. If you minus a, the graph goes down. Now for the horizontal shifts, if you minus a, the graph shifts to the right. And if you plus a, then the graph shifts to the left. And that is the overall rundown of function on the SAT. Great work today. Keep practicing and you'll be ready in no time. If you find this video helpful, please like and subscribe and share with a friend. See you next time.